I'm Kurt. I'm talking about Lighthouse, and I'll tell you what Lighthouse is in a minute. I think the better title for this talk is React Giveth and JavaScript Taketh Away. So that's what we're going to talk about. Lighthouse is a tool for measuring speed of applications. I've been shocked to find out, since I started working on this, that some people don't care. It's a very strange thing. So I've learned to start pitching people on why speed matters. And the reality is speed matters because you make more money and you get more users, and also for pride reasons. So I have this huge page of speed propaganda, if you don't believe me, that I'd love to talk about later. But right now, hopefully you all think speed matters, because that's what we're talking about for 22 minutes. Like I said, or he said, my name's Kurt. I have worked at several companies. I helped build Ars Technica. I even wrote a terrible review of Mozilla back in like 2000 for Ars Technica, which is very cool. They got bought by Condé Nast. They're over in the Freedom Tower now, right? Built a company called Compose. We did hosted databases, which we sold to IBM, and their building is over there. There's buildings all over for places I don't work anymore. And then I'm now building a company called Fly, and Fly is a global application runtime, and the idea is that you build your apps, you deploy them to the edge, so you're not having to use like Lambda at edge. You just write your app and it runs everywhere, and you don't have to make CDN choices anymore. But the primary reason Fly exists is for speed purposes. And you will probably discover a little bit of my agony along the way. I have some slightly angsty slides you get to enjoy. So, boy, I didn't take that transition out. Okay, Lighthouse is a tool Google created that it assigns a score of 0 to 100 that's supposed to sort of match the human perceived performance of an application, specifically an application that you're loading for the first time. So there's this sort of spectrum of applications that Lighthouse is really good for, where you can think of them as like publishing companies, where they have kind of similar content they show to lots and lots of people, and then all the way down to the scale of Facebook, where everyone who logs in sees entirely different stuff. Lighthouse is really, I think it's useful for the entire spectrum. It's really useful for these types of sites where like the first impression happens a lot, and you will lose people immediately if performance doesn't work. If Facebook is slow to load, you're probably still going back tomorrow. If Levi's.com is slow to load, you're probably not buying jeans from them that day. It's kind of that distinction. But it's a very, very neat tool, because all the businessy folks at companies that don't understand what time to first byte mean can wrap their head around a Lighthouse score and how important it is to users. React is really good at Lighthouse by default. And a lot of this, and we'll get into this a little bit later, is because it's modern, and browsers are modern, and React has components, and it loads things in a way that Lighthouse likes. And a lot of what Lighthouse scores come down to how you actually load your resources. So this talk is a lot about Lighthouse, React applied, and then some other bits that it's useful to really understand what's happening with or without React in the JavaScript app loading world, with kind of React layered on top. Discovery.com is a modern React app. I have two caveats to the rest of the presentation. One, if you worked on this app, I apologize. Two, hold tight, it gets better. So, Discovery.com is on the spectrum of publishing company. They get millions of users a day see this site. They care about some things, and it just depends on which page what they care about. But it's not a Facebook level React app. This is sort of a publisher level React app. So arguably Lighthouse is incredibly important. So I ran Lighthouse on Discovery.com, and there's a few very important components of a Lighthouse score. The first is, what is the first meaningful paint? First contentful paint, which is the first time anything really shows for a user. The second is first meaningful paint, which is kind of like the hero sort of above the fold bit of the app is actually kind of complete. In this case, for Discovery, it happens when the shark loads. And then the last is time to interactive, which is, can the user actually interact with this app? You'll notice that Discovery.com scores a 5 in Lighthouse. And as I said, the score is 0 to 100. The 5 is like lower 5%. And a lot of that is derived from these three numbers. So in general, you want to shoot for a first contentful paint of under 2 seconds. You want the gap between that and the first meaningful paint to be as small as possible. And then time to interactive needs to be something like a human will wait for, which is typically about 7 seconds. So this page is painful for users that don't block ads. The reason the score is so low is because Discovery.com, like every publishing company, runs a lot of third-party JavaScript to do things like A/B testing and analytics and ads. It's always ads, right? And this just murders the score. So the very first thing my low-res angry balloon here did was let's just run it with Ghostery, which will block a lot of the third-party stuff because it's privacy, right? Ads are not helpful for privacy purposes. And you'll notice that the metrics are all a lot better. Specifically, time to interactive, it's half. So my little clock there basically started 11 seconds counted down, and then we have a fully functional page at this point. Another little sort of asterisk here. This is sort of a simulated page load. This isn't, Lighthouse by default will actually show you the mobile view, but I wanted to show you roughly what you'd be seeing if you were on like a widescreen display. So just by turning off everything that makes discovery money, we've made the page twice as fast. And we've upped the score from 5 to 36, right? And this is agonizing. If you built this app, this sucks. Like this has been going on for 20 years. Like there's been this tension between what I let other companies inflict on my application and what my application actually does. And it's getting better. The world has to change, but it's still an impossible battle. So by default, we're just going to ignore all third-party scripts because nobody in here can affect that right now. Nobody has like the political cachet to say shut off all the ads until they conform to our speed standards. It'll happen. It's just going to take a while. All right. So now that we've gotten like Discovery's not making any money, but it's a little bit faster. We can actually go hog wild and make it as fast as we want. Lighthouse has a really useful tool for explaining what you need to do to get a better score. Number one, serve images in next-gen formats is not React specific at all, but like 98% of the sites on the internet have this problem. You don't, like browsers can do much better things than JPEG and PNGs at this point. So like most everything WebKit based can do WebP, which tends to be 40 to 60% smaller for visually exact images. Mobile iOS can do JPEG 2000, which nobody's written an encoder for, so you can make it work, it's just nobody really bothers. And these are ways with two really popular and one my company to turn this on for your application. And this is the only time I'll be really promoting what we're doing here. But if you're using a CDN that's not CloudFront, because Amazon's CDN is very basic, you can just turn on WebP for any browser that can detect it. If you're writing an Edge app with us, you can just turn on WebP for any browser to detect it. So it gets our score up. We went from a 30-ish to a 46 at this point. And what you'll notice is that the first contentful paint came a lot faster. We're down under 3 seconds, which Lighthouse likes. First meaningful paint's actually a little slower. And then time to interactive slowed back down. So that was really confusing, right? Oh, man. All right. That one wasn't animated, but you've all got the gist of the loading images at this point. Whoa. So this one's, I'm failing my transitions. So what ended up happening when I ran this Lighthouse thing is it said defer off-screen images came up, which is a happy accident if you've ever met Bob Ross or watched his painting show, because I wanted to talk about lazy image loading. Man, you didn't get to see Bob Ross very long. We're going to wait another couple seconds and see him pop down here. Bob Ross. Loading images is surprisingly complex. That image tag is not very powerful. So the HTML5 has introduced things like source set and picture boxes. And what these are is ways to give the browser the image size it actually wants, which is not exactly loading images when they need them, but this is something the Discovery folks did really well. When you load up, if you load up their app in a browser or on a mobile device, it'll actually give you the size image you want using this picture selector right here. And if you look in there, you can see the widths that their image API is generating for each one. What's interesting is this is what we want right away. This is the thing that matters the most at the first page view. And then this one we want later. This is the thing that you don't actually want to give people until they need it because it's not visible and it affects the Lighthouse. I'm saying it affects the Lighthouse score. What it really means is it's making everything slower. So what happened with my test is we failed at that. We broke the lazy loading that was happening on Discovery, and it made everything actually slower despite having a slightly higher Lighthouse score. So humans shouldn't write that HTML. They shouldn't actually write image markup for anyone, which is why we have things like React to help us write image components. This is an image component we've implemented for cars.com, and this is actually rendered server-side. And what this does, and this is what I would call Slido code, so it doesn't actually work, it just looks like it's on a slide. But what it basically does is it takes an image URL, it takes a list of sizes you want, widths. It takes a list of widths you want. It generates that HTML for you, but then this one gets a little cleverer. And what it does, and you'll see that up there, the LQIP is shorthand for low quality image placeholder. And what this does is it gives you back a very small, very blurry, not great version of an image that you can inline in the app itself so it loads instantly, and then you can bring the full powered, like high fidelity version back. And the effect that has on performance is we're down to 11 seconds, so you only have to sit through 2 more of these. right? So our numbers are improving again. We're back to time to interactive, so we sort of unblocked how long it takes to get that menu to function by making images load the way the discovery people already did. One interesting thing about lazy loading is it's great for Lighthouse scores, but it's also pretty good for the user experience. This is what you see when you first load the page. Depending on your connection speed, it'll sit here for 2 or 3 seconds, and then you'll see this happen. It's not the best, humans are that's jarring, right? We went from solid black to this very neat shark illustration. The lazy loading what you do is let you have a blurry Rhonda. So this is a 4K embedded image of Ronda Rousey. And what we did was we took the big master image, we shrunk it down to 120 pixels wide, and then we blew it back up with the HTML. And it's now inlined in the page, so it loads instantly. And then what happens when they get there is it just suddenly fades into very high fidelity. It looks really, it's actually a really neat effect. There's other techniques you can use for that. So the image component we use and the image components you should probably all be using in your apps take care of that for you. In conjunction with either a CDN or an edge application runtime that'll let you do the blurry images. So what else can we improve? Now that we've unblocked our images, we get on to, all right, these are things that have to load before we can render the rest of our page. And this is again, Google's cheat sheets are really great for this. So we have things loading that the Lighthouse doesn't think we need. And Lighthouse is very specific about this. It will know that you don't need that first CSS file until the page is been scrolled, for example. So basically you can just follow these sort of dumbly and make it work really well. Loading assets is really easy in the React world because we have HTTP2. You don't do things, you don't bundle one big JavaScript file anymore. At this point, it's 6 years old, which is decades in the internet world, right? You do what React does, which is you take each component, you break it up, you let the browser be smart about caching and loading the ones it needs. You use async or defer module in your script tags. You kind of bundle the CSS to match the modules you need, and you can do some very intelligent loading. It's very nice in React world. React loves HTTP2, it loves defer. And so this is a Slido code again. I just chopped down what's in the Discovery app to show you exactly the components it has down there. What defer does, if you're not familiar, and it's worth sort of understanding this, defer says, I've seen you, I recognize that you're here, and I will get back to you after I place you on hold for a little bit. So it sees the URLs for the scripts, it keeps track of them, it knows that after it's done rendering and executing any script that's not deferred, it can get back to these. So it's great for I have my embedded blurry Rhonda and all my HTML and I want to take care of that first, and then I want to get these scripts later to sort of enhance the experience. What's interesting about this particular thing is these are 3 third-party libraries that are blocking rendering again, right? Remember that angsty slide earlier about how bad third-party JavaScript is. Those are, again, 3 things that have nothing to do with the Discovery app that are holding up my experience watching it. What's interesting is I don't have this, anyone who runs an ad blocker gets a great experience. Anyone who Discovery makes money off of gets a terrible experience. It's very unfortunate. So loading assets isn't really as simple as it should be because you have to contend with other people's code. And the people who write third-party JavaScript are not great JavaScript developers usually. It's usually the cheapest people an ad tech company can hire, and you're lucky if they don't use document.write, which will just replace your whole app with a blank page. All right, so we ripped out more third-party assets, right? So we're down to almost 2 seconds for the first paint. We're at 2 seconds for the first meaningful paint, because what we've managed to do is we've managed to unblock the browser, and it's able to grab the image while it's still rendering the layout, and it does those things almost at the same time. Time to interactive is now under 10 seconds, which is actually getting pretty good. Lighthouse simulates a mobile device, and the reason for this is mobile devices aren't really getting faster, they're getting stagnant. The mobile devices you buy now are cheaper than they were 2 years ago, but they're basically the same speed. So Lighthouse is an interesting look into, we're probably all using modern iPhones and nice laptops and things. Lighthouse is a relatively good way to simulate what most people are seeing. And so under 10 seconds is actually pretty good, sadly. So this is sort of a truncated talk, and I think most of these, you could do an entire talk on image loading, you could do an entire talk on how to actually use modules in your React code and what to give browsers. You could do an entire talk on third-party JavaScript if you wanted to do that. And so these are we did basically 3 things to go from a 30-ish. I don't really think going from 5 to 30 counts. We went from a 30-something Lighthouse score to about a 69. You really want to get to 90 plus. And what 90 plus sort of suggests is you're in the top 5% of the best performing apps on the internet, which there's a lot of apps on the internet. It's a nice way to differentiate yourself. If you care about SEO, it's a nice way to get better SEO. So what you'd actually do to take the rest of this page to 90 is you'd inline the CSS you needed for that hero image. If you noticed, one of the blocking assets was actually a little CSS module for that particular component. You'd go look at what Gatsby does. If you haven't messed with Gatsby, Gatsby is a React-based static site generator. And it's actually very fascinating. What it does is it renders a complete self-contained HTML document for each article or thing it's doing that loads incredibly fast, like 90 to 100 on most sites, unless you've done something silly. And then what it does is it wires up React, so when you click on a link, you're not loading the bloated page again. You're actually just, you're triggering a React event and everything's happening very fast. It's really astonishing to go to most sites and then go to a Gatsby-based app and then click a link and it basically repaints the whole document before you've even seen anything happen, even if you're just clicking on like About Us and looking at people's headshots on a company. And then get rid of the third-party JavaScript, which I couldn't even write again. Oh, right, one more thing. The Discovery app has 300K of React state in the HTML, which is huge and slows things down. In fact, it's all redundant data. So all of these things are also HTML elements. And I was kind of surprised to see that. And so what's interesting is it gzips down pretty well since it's redundant data. So like all those URLs happen twice. It's really easy for gzip to do its thing. But un-gzip size of assets is a reasonable proxy for how long it takes a browser to kind of parse and take it apart. And so they're using something called React Transmit Packet. It's a library I haven't used, but it's a state management plus, I think, if I read the GitHub repository correctly. If you could actually get rid of this, it would have even improved our score a little bit more. All right, so that was a whirlwind tour of Lighthouse with a little bit of React dabbled in there. If you care about this stuff, you should definitely go look at Google's docs on Lighthouse. They're really good. You should look at Gatsby.js. You should actually use it to generate a site. It's very interesting. You need to look at script defer. And what's fascinating about a lot of these types of things is they're new and they're really well supported if you care about everything except IE11, which is very old at this point. But there's also ways to use defer and fall back to an IE11 compatible thing. And then this is a really interesting JavaScript library. It's not React specific, but you could wire up to React pretty easily. That takes, and it manages lazy loading of everything. And so you can make it act on if you've not used the image observable API in a browser yet, what it does is it lets you trigger an event when the element you care about gets close to being in view. And so lazy sizes is just a nice way to not have to rewrite all that JavaScript. And then also, I actually really like getting criticized nicely. So you should, if you have ideas or if there's things I didn't cover or if you didn't think something was quite like relevant for what you're here to see, I'd love to hear about it. And so feel free to email me or at me on Twitter and then talk to me after. But otherwise, thank you very much. And I probably have time for 1 or 2 questions. Do I know of any alternatives to Gatsby that require less configuration? It depends what you're looking for. If you want just a static site generator, like Hugo is awesome, but it's written in Go and has nothing to do with React. If you want to see like how React would work if you had a static site to generate, Gatsby is the only thing I know of that does that very well. I think one of the big problems Gatsby has, particularly at the companies that are customers and like Discovery, is that it's really easy to make a nice isolated Gatsby site. It's really difficult to make the rest of your application behave the way Gatsby does. And I'm hoping they improve that because they just raised a whole crap ton of money, so we'll see. Do I think server rendering and then hydrating the app makes more sense performance-wise, or just spit out the app and let the browser do the thing? I'm actually a tremendous fan of server rendering, and one of my dirty secrets is most of my React work is not on the client side at all. It's a lot more, if you've seen how Netflix does their app, what they actually do is they render the markup. They ship it to you. They ship a tiny JavaScript shim that makes everything work, and then they load the rest of React later down the road, which is a lot closer to the type of work I've done. Server rendering is insanely important if you care about SEO. Google will actually spider and run your JavaScript, but we've tracked how long that takes. It takes 2 days. So basically, they'll crawl the page. 48 hours later, you'll get a weird, like really late page load event. It's very interesting. It screws up all kinds of browser tracking that we've tried to do. So it takes them a while. And then the other thing is like server rendering is really the fastest way to get to that first, what Lighthouse cares about. which again matters for SEO, but I think it's just like, if you're doing apps that you don't download from the App Store and are web loaded, it's just the best way to get that good first experience is to. Now, I also griped about how big a state was in the HTML, so like it's not an easy problem, but I would definitely server render.
So you would go back and get that state later asynchronously to the first byte.
Yeah, exactly. And I would try, and I think this is one of the things like Redux in particular is meant for Facebook style applications and not necessarily for discovery style applications. Depending on what I was doing, I'd look at Preact, which can rehydrate without doing this. It can actually discover that from the nodes. Or just, make it do like Netflix and maybe not hydrate with React exactly, but bring it in later and have like later HTTP requests do all that work. Thank you. Thank you.